Hello, everybody. Welcome back. Today we're going to be talking about function transformation, right? So just a quick review. Function transformation have this kind of form right here. Sometimes you have the negative in front, sometimes you don't, okay? But the negative in front, it just means that the graph is being reflected across the x-axis. Okay? And then, well, sometimes you have a positive number, so it doesn't change what is the graph looks like. A is the number that in front. We call this one is the leading coefficient. So two cases for this one. If A is greater than 1, if the number is bigger than 1, then your graph is going to be vertically stretched. Okay, vertically stretched. And then if the opposite, if A is between 0 and 1, then your graph is going to be vertically compressed. Okay, and so we have that is the beginning of the graph, the function, and we have the middle part when we have x minus h, then it's going to move your graph horizontally. That means it's either go left or go right. Okay, so we have x plus h, then your graph is going to move to the left h unit. Okay, and then if we have x minus h, it's going to move your graph to the right side. Okay, so that is in the middle of the function. At the end, sometimes we're going to have the graph that have adding or subtracting. So you have a positive number at the end, then we're going to move your graph up. And then if you have minus k, it's going to move your graph, translate your graph going down. Okay, so that is a review of general rules. We're going to take a look at the example at the bottom right here. All right, so we have f of x equals x squared. Remember this name, the name of the graph is quadratic function, okay? This one, quadratic function. Is transformed to create g of x. Describe the transformation. So g of x is a new function right here. It's being described, transformed from the f of x. Okay, so we're gonna describe this. We have three parts in here. We have the front, the middle, and the back. Okay, so a number in front, let us know if your graph is being stretched or compressed. So we are going to compare this one into 1. Okay, 1/3 is decimal is gonna be like 0.33, right? And the 3 repeated. So we call this one is a number that's smaller than 1. So this is the smaller number than 1 means your graph is gonna be like it's looking down. So it's gonna be vertically compressed. Okay, we have a vertical compress here. So there's no negative, so your graph doesn't flip or reflect it across x-axis. Okay, next we like taking a look at the middle part when you have x minus 6. When your graph goes to the x minus, then it's gonna be subtracting a positive 6, right? So your graph move to the right 6 units. Remember everything that in the middle right here is opposite. Okay, it's moving up the opposite direction of what the sign looks like right here. All right, and at the end we have a plus 3. In the back we have a plus 3. What it means to the graph is gonna make your graph go in up 3 units. Okay, so your new graph is gonna look like, still gonna look like a U shape like that, but it's gonna be vertically compressed up 3 and go to the right 6. All right, so that is the example about the general rules. We're gonna take a look at some more examples, okay? So let's take a look. Example number 1. If the function f of x is changed to g of x equals -1/2 f parenthesis x minus 2 plus 5. How is the graph of the function transformed? Okay, so for this one, remember the name of the function that we are being described. This one is called the absolute value function. Okay, absolute value function. All right, so it looks like a V shape like that. We are going to describe the new function, which is the g of x right here. Remember, this is the new one. So we're looking at everything that popping out. Number one is a negative in front. Okay, so, and then we have 1/2. In the middle, we have x minus 2. Well, normally we have f of x, but now we have x minus 2. Of course, it's going to make your graph move as well. And at the end, in the back, we have x plus 5. Okay, so we have 4 things that we need to describe. The first, when you have a negative in front, what it means is going to make your graph reflect across the x-axis. Okay, so the negative means making your graph reflect across x-axis. And then after that, we have a fraction. Well, but we need to compare this fraction into 1, right? Well, comparing to 1, 1/2 is certainly is going to be smaller than 1, but and it's positive. So we're going to have it's vertically compressed. Okay, so the new graph is vertically compressed. Next, we have the x minus 2 in the middle. So it's going to make your graph, whenever it's with the x, it's going to move your graph either left or right. Okay, and remember the opposite. The sign right here is minus 2. So your graph is going to be moving to the right 2 unit. Okay, at the end, in the back, we have a plus 5. So what happens to the graph is your original graph, your absolute value function is going to be moving up 2 units. Oh, my badness. Not 2. It's going to be exactly the same number. Okay, so we're going to have 5. There we go. So we have 1, 2, 3, 4. Boom, 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 boom. 4 things that being moved to your graph, right? So right now, it's still going to be in the same family of absolute value function, but it's transformed a lot. Okay, here we go. Let's take a look at the second example. All right, what transformation has occurred to create a graph g of x equals 2 parentheses f of x plus 4 from the graph of f of x equals x squared? Okay, so as you can see right here, the regular function, the normal function is this one, right? The original, because this one is quadratic. All right, at this time, you should be able to distinguish between quadratic function and absolute value function. Okay, that's why I'm still rewriting it again and again and again so that you can remember. All right, so we are going to describe this new function, right? Comparing to the original, f of x, original. We have some new things are being added to the graph. So in the front, we have a number 2. We don't have a negative, so there's no reflection. 2 is positive and certainly is greater than 1, right? So what it means is it's just gonna make your graph double in height. Okay, so we call this one is vertically stretch or vertical stretch. Okay, then we don't have anything in the back, but we have something in the middle of the function. We have parentheses x plus 4. This case, it's gonna move your graph to the left 4 units. All right, so that's it. We just described the new function, how it looks like, okay? Of course, there's ways that you can check this one on the graph. I'm gonna show you how you graph this one, okay? The first one is gonna be you put in the original and then you can check, confirm your answer by graphing this one. But you gotta put in what is the f of x, right? So f of x is x squared right here. So what happened to that is then you're gonna move this one so it look kind of the same like this, right? We have f of x is x squared and we transform that one. So we're gonna take everything from the f of x and replace that with the x squared right here. So we have a number in front, it's 2. And then we're gonna keep the f of x the same. Right now, we're going to have the x squared. However, we add in 4, right, to the x. So we're going to have inside the parentheses is x plus 4. And then we're going to keep the square outside like this. We don't have anything being added or subtracted to the back. So this is the graph, the new graph that you're going to compare with, okay? Let me show you in decimal how it looks like. Right, I'm splitting my screen right now. So the original function was x squared. So when you put in here, remember to use a keypad on the bottom, okay? So type in x first, and then you're gonna put the square like that. So that is the parent function, quadratic function. Then we're gonna put the new one in, okay? The new one we have is 2, and then parenthesis, x plus 4, close parenthesis. And then remember the original have a square, so we're gonna put the square outside. This time it's gonna be outside after the parenthesis. So as you can see right here, the graph is being stretched. The new graph is blue graph, right? It's being stretched out, so it's thinner, and then it's moved to the left 4 units, just like how we predicted earlier, based on the rules. Yeah, so there we go. Let us take a look at 2 more examples. Now, this one is gonna be a little bit different. It's gonna make you think a little bit, okay? You need to write a new graph based on what they're given. So here we go. Function f of x equals x squared is transformed to create g of x with these 3 conditions. Reflection over the x-axis, vertical stretch by a factor of 2, translation right and up 4. Okay, so we're gonna identify every single one of them. First, reflection. So this is the original, right? Remember the name is quadratic function. And then we are going to start with that one, okay? So f of x looks like this, x squared. So we're gonna start adding things into this one, okay? So we know that it's gonna be reflection over the x-axis. That's mean the negative in the front. Okay, so let's put a negative. Vertical stretch by a factor of 2. So every time that you see a factor, that means it's being multiplied, right? And that's a leading coefficient. Yeah, so we're gonna put the 2 right after the negative right there. So we're gonna put the, right here, that's 2. Gonna put after the negative. So next, we have a translation right. Oh, every time I hear right or left, I need to remember that is going to be a parenthesis, right? And then it's going to the right, so it's going to be x minus 2. Cool? So I'm going to put x minus 2. But then comparing to the original, I have the square right here, right? So where are we going to put the square? Well, the graph doesn't go down 2, so it just goes to the right. So we take everything and move to the right. I mean, we're gonna take square outside. And then at the end, we have an up 4. Up 4 means you add 4 to the back. Okay, anything up and down, remember you put them at the end. Okay, so the new function have negative 2, parenthesis, x minus 2 square plus 4. It's always gonna look like similar to the parent function, right? There we go. If there's x squared, you put x squared after the parenthesis. All right, so that is writing the new equation based on the description. Next, we take a look at the right side. F of x equals absolute value of x. Remember the name of this one, absolute value function, okay? It's being transformed to create new function right here, g of x. So g of x have vertical compressed by a factor of 3/4. Again, we were the word factor, that's a number in the front, okay? That's a leading coefficient right there. So we're gonna have 3/4. Remember our original looks like this. Okay, so our new one is also gonna look similar to that. So I'm gonna have some absolute value bar right here. And then the next one is say go to the left right here, 2 units. So anything to the left, it have to be inside the parenthesis, or in this case, inside the absolute value bar. Okay, so we're gonna have right here is x plus 2. Remember opposite sign, okay? We're gonna put this one inside the absolute value bar. It's going to the left 2 units. That's mean absolute value of x plus 2. And then at the end, we have an up and a down. That's the easiest one, isn't it? Up and down, it's just gonna move your graph down 3. So that's mean you're gonna have minus 3 at the end in the back. So put minus 3 right there. Okay, let's double check. Number smaller than 1, vertical compress. And then x plus 2 means go to the left 2. Minus 3 at the end, moving down 3. And that's it. We have written our new function for the g of x. Thank you for watching. I'll see you in the next video. Bye.